Hello. Good. I have audio.
Hello.
How's it going?
Going okay, how are you?
I'm all right. Living
Living the
the
dream?
Yeah. Maybe I'm dreaming? I don't know. What year
Your
is
audio worked in the first time, so maybe it's a dream.
it? Everything's a simulation running on the cloud. And yet we work on the cloud.
Are we in the metaverse?
I think we're the masters of our own universe, I think is what it is. I'm going to go program me a yacht.
You
I know
wouldn't
why.
download the yacht.
What's that?
You wouldn't download the yacht.
But I might upload one.
If you build it yourself, it's fine.
But I forgot to upload the docking fees. Sorry, go ahead.
There's a
You
fire
put
alarm here. Can you hear it? No, that's good.
3D printers are getting pretty good. Maybe you can download a yacht.
I mean, I remember there's one episode of Mythbusters. They build a boat from duct tape.
Really?
Yeah,
Just duct tape?
Like, yeah, duct tape for the framing as well, or
no, just the whole. I mean, not the framing. The framing was metal, but anything that touched the water was duct tape.
I'm guessing it worked.
Yeah, it worked. Yeah, it was pretty cool.
Duct tape is heavily used in space. So if it can stop vacuum, I think it can stop vacuum.
Yeah, about when that sub accident happened, one thing that people were pointing out was the difference in atmosphere between like vacuum and Earth, right, versus deep sea and the surface of the Earth. The deep sea is actually the harder situation. So I guess I'm asking, did they build a submarine out of duct tape?
Not yet. I feel like we have more energy at the 2 p.m. call than 9 a.m.
Petition to move every call to 2 p.m.
Hey, that's not a bad idea.
What were you gonna say, Davis?
Oh, last time I was on a flight, one of the wings was just like heavily duct taped. It was not the most reassuring.
What airline is this?
Is that Spirit?
It was like some weird Asian airline that doesn't operate domestically. I forget. Like Air Malaysia or something. I don't remember.
Asiana?
Yeah, but it was not a good look. Not a fun flight.
What was the airline?
No, I'm out of here.
Right?
Yeah.
Well, there was it was a Malaysian flight that went missing years ago, right?
Oh, that's true. I didn't make that connection. Yeah, I looked it up after though. Apparently it's called speed tape and they like use it to temporarily secure stuff before they can actually repair it. Looks like duct tape though. I don't know.
But
yeah, I think there was a viral tweet that just happened. Like somebody took a picture of that and then asked Boeing, like, "Hey, is this okay?" or something like that.
Oh, really?
Yeah, that just happened.
What What did Boeing say?
I don't remember. Let me see.
But they always say.
Yeah. After 737, everything is.
Unfortunately, we cannot comment.
This is CNCF after all.
Wait, so that's so interesting. Like, if it's a temporary fix, meaning there's a better fix that you want to do for like realsies, why would you fly with a temporary fix with passengers?
Because you can't afford to cancel the flight.
Probably. Like, I kind of get it. It's like, it's kind of like, well, you can't really tow an airplane. Maybe you want to use that tape so you can fly to, like, the body shop airport or whatever. Move fast and break things. Move fast and break wings. I just loaded the picture.
Yeah, I think there's like a few of these ones. I looked, like, I Googled this and there was like a bunch of them.
Is this what you're talking about, Davis, or different? Like these.
Yeah, I mean, it wasn't that bad. Like, there wasn't that many, but it basically looked like that.
Yeah,
Far
apparently this is like a
better
thing,
than
like-
what I imagine. I imagine they're wrapped around like this.
Yeah. Like holding the engine on.
Yeah.
That's not good. It's called speed tape. It's not duct tape, it's speed tape. Oh, that's the
It makes the plane go faster.
yes.
Do we want to? Oh, I saw a speed tap because of how the text wrapped for me.
Oh yes.
I'm not sure I can demo after this heavy conversation.
The bar is high. You need
Very high for
you need to use duct tape or speed tape in the demo.
Oh, can be used to protect sealant while curing. All right, I'll accept that. It's like a Band-Aid on the actual fix.
I mean, I wonder if they could have used it in that amusement park that like got cracked.
It can patch non-critical components of an aircraft. Are wings critical? Do we need those?
I don't think so.
I hope so.
They're just there for looks. All right, do we want to do the meeting?
All right, let's do this. Okay, go for it, Nilik.
Okay, let me share the screen. Okay. So just a quick context, right? So we have the data replication that we enabled today, right? So one of the idea that we have been thinking, Saptash and I were talking about this is with data, like when we do a replication, it has a memory implication, right? So is there a way, or like a middle ground with which we can probably improve this, because this can get out of hand as the cluster, the number of resources in the cluster increases, or the bigger the cluster gets, right? So that's what we have been thinking. And then one of the things that we thought is like, hey, can we do this with the external data providers? So what if we write external data provider for the Kubernetes API? That's it. So for example, if we take our ingress example, right? So every time somebody creates an ingress, instead of validating that the uniqueness of the host, instead of validating that with the cache data, we can actually pass on that request to the external data provider, and then it can query the cluster and basically tells us the accept or deny. So that's basically the gist. And let me run through the demo real quick. It's really simple, and then maybe we can talk about this further. Let's see. So I have created a cluster. I have installed the external data provider for this Kubernetes APIs, and I have created like a bunch of ingress. And I have this standard ingress constraint with a deny policy. And the constraint, of course, which will call the external data provider here. So I'm just grabbing the host and passing those host as a keys to our K8s external data provider. And just so that we know, like I have recreated these three ingress, like test1, test2, and test3. So if I try to create the ingress with the same host name, it should basically deny it, saying that the duplicate ingress host. So this is actually run and denied by the external data provider rather than doing those decisions locally. And of course, like if we send the correct ingress, then it should work. So that's basically the gist of it. What it's like a quick demo that I wanted to show, and maybe my idea is to just like probably chat with you all and see what you all think about it, and does it make really sense? Is the trade-off worth sort of looking into these kind of things, or what do you all think about it?
So I'm trying to suss out, looking at this and how you're querying the provider. You're just querying it with host names. So is this provider written specifically for this constraint? Like there's logic that says I'm gonna scan through ingresses and find ones with the appropriate host name?
Correct. Yeah. So right now, so I haven't created a generic thing where you can provide a kind and it can query that. So right now I'm just like straight away hard coding ingress, and I'm just querying ingress, all the ingress in the cluster. But I could see like we can do generalization that like we can probably send a kind, or we can start watching different kinds in our external data providers, and depending upon request, we can query them.
Yeah, or use like a fully qualified key, right? Group version kind,
Yep.
namespace name.
Yep.
Okay, just wanted to clarify there. I have a bunch of thoughts. I don't want to like, take up all the airtime, but some high-level stuff that I think about here would be, the first one would be security. Right? Like if you have an external data provider that's a middleman between Gatekeeper and the API server, that external data provider is presumably going to have whatever permissions you need to support whatever constraints you want to write. So then it becomes important to lock that down. So that's probably doable because of MTLS, but it's kind of critical. Another concern I would have that again is probably pretty readily addressable would be side effects. You probably don't side effects like creating a resource via this external data provider, which could technically you could write a provider that does that. That you probably don't want to do that. Go on.
I didn't get that part. Why would you want to create a resource with external data provider?
Oh, I don't think you would want to, but you could. And so I'm just highlighting you shouldn't.
Okay. Right. Right.
Yeah. I'm looking at the usage pattern generally, not the specific example.
But that can be easily dialed down, right? Or restricted, basically. Like the external data provider can have explicit read access per se, because it just needs to read the data in the cluster and then validate. It doesn't need any right
Right.
permission as far as
I think that's like our back, but we cannot really like say you cannot do that. But yeah, like any provider can do whatever they want.
Right.
Oh, I see.
Yeah,
But
this
yeah,
is just
we can give best practices, but yeah.
Right. Got it. Yeah.
yeah, this is all like guidance. Some of it is probably obvious, just being explicit about it. From a systems design perspective, there is a bit of a circular dependency this creates, right? Where an inbound request, in order to evaluate it, now you need to read from the API server, right? So I would be a little careful about failing closed, for instance, if a user wanted to use an external data provider like this. It may not be impossible, but there's a whole bunch of nuance that would need some careful thought. The other interesting bit here would be the potential for read amplification, right? And in some ways, this is designed to address that. In other ways, it doesn't help, right? So you can kind of compare 3 straw man or maybe steel man solutions, right? There's if you want referential data, you can do what we currently do, right? Which is watch resources, but that has a cost of RAM usage on the local host, also resource usage on the API server of establishing those watches for relatively rare requests. Maybe that's not super helpful. Then this is more strawman, but an approach that just purely directly reaches out to the API server, right? No intermediary, no cache. That would be bad, potentially, because you could get read amplification, right? Like, I want to create one ingress. Now I'm reading 10,000 ingresses to make sure that its host name is unique, right? And so the traffic magnifies, and you can run the risk of DOSing yourself depending on the contents of the cluster, the request, your policy, etc.
Right. One of the things, sorry to interject with that. One of the things that I was thinking, and let me know what you think, but potentially we can implement caching within that provider itself. Maybe that can help us to sort of reduce some pressure on the API server, memory, and other ones, right?
Yeah.
But again,
Yeah,
that's gonna be a trade-off.
I was purposely doing a bit of a straw man, ignoring caching, just to like show the easy like failure mode. But with caching, there can still be concerns, because caching that request still needs to happen. Right? Like, if you have 10,000 ingresses, right? They need to be refetched every time that cache expires. And it's not like watches are immune to this problem either. Like, watch, you run an initial list to populate your cache, and then you receive the deltas. And if the resumption token is old enough and you lose connectivity, you need to relist. So it's not like I want to be clear, I'm not talking about, hey, this one solution is obviously superior to any other solution. I'm just dissecting the infrastructural implications.
There is a streaming watch which is in alpha.
Yeah, although I kind of saw, correct me if I'm wrong here, but when I saw that, it looked like what that would do is it would run the initial list, but kind of give a placeholder for every entry in the list, right? You would just get like the group version kind namespace name, let's say, rather than the full resource. So then if you needed for that initial listing, and then events would populate things over time.
Actually, the way it does is it will give you actually a full list of resources from the resource version that you mentioned, and from there on it provides updates. So you'll receive a bookmark event after that, and then you can use that pointer to further sort of continue to watch on the updates of that list.
Right. So let's say I establish a watch on pods, right? And there's old pod 1 through 1,000, right? And then everything created after is new pod. And so at the moment I start the watch, only old pods exist.
Right.
And then I'm watching, and so every new pod I receive as an event. But let's say I write a controller, and that controller says, "Oh, I have an event for old pod that I need to process." Right? This is an inferred creation, let's say, because we're bootstrapping a new pod. Does it need to reach out then to the API server to read the contents of old pod?
No, it should directly give it to you, because you said you're already watching these number of RVs when you initiate the.
So the scenario would be, I am a pod that I shouldn't have used pod because now I'm using pod in 2 contexts. Whatever. I am gatekeeper, and I want to watch pods, and so I'm spinning up a new gatekeeper in a pre-existing cluster. And I receive this like placeholder list, right? And I start receiving events. But I have a controller that's running through all of the pre-existing pods, right, to cache them, right? Because I've established a watch. So the placeholder isn't sufficient at that point, right? I need to get the contents of the pod so I could cache it. So my question is, does that mean then that I would fall through and reach out to the API server directly? Or
I think the streaming list would do that for you. Because the way when I was reading through that cap, right, the way I looked at it is like it will give you an event, and it is guaranteed to give you the consistent list from that point on, or to begin with. So I need to check out. I need to check basically how the actual implementation is in this case, what you are mentioning.
yeah, because I thought they purposefully gave you a sparse list to make that initial list request a little more efficient, so that they can paginate with less risk of expert.
That's the thing. There is no pagination. This was implemented. There is no pagination in that. This is specifically implemented to avoid paginations.
Okay, so then they return a sparse list, so they don't need to paginate it. But either way, my concern would be the sparsity, right? And then what that means in terms of like when you actually need the data.
Okay, well, might kind of makes sense. Anyways, but I think that's a good point, and maybe we can. I'll look into that more.
Yeah, I mean, if you find out, let me know, because I saw that. I just noticed it, I think, last week, and I was curious.
Right.
Like, because that was my first thought is, well, okay, but a controller is going to need that data. So
it's definitely not a sparse list as far as I know, because I've been reading into that for the other cap that I've been writing. But anyways, I think for the, I mean, I don't want to go into the details on this call, right?
Yeah, kind of got nerd sniped. But anyway, the concern would be with regard to the or not concern, just consideration with regard to something. The Kubernetes data provider would be you're changing the load profile and how the system responds to events, right? Caching doesn't completely wipe out the read amplification problem. It does ameliorate it, and it does make it more intermittent.
Okay.
So maybe the data provider can do some interesting caching things on its own. there's no reason why a data provider couldn't establish a watch, right? You could imagine like some sort of infrastructure where if the excess number of watches were expensive, you could have one central thing doing the watches and multiple gatekeepers reading to that central thing. What would make sense just depend on the reality. Good.
Yeah, that was one of the motivation, I guess, and I think Sardas can probably shed more light on that. But instead of when we do that replication today, it gets replicated to each and every pod that the controller manager pod, right? So could that be centralized? Is one of the aspect that we had.
Yeah, and then we don't also put everything in Gatekeeper itself, so Gatekeeper doesn't run out of memory.
Yeah. I mean, yeah, the data needs to go somewhere, right?
But if you can offload some of it from Gatekeeper, right? So then the Gatekeeper itself can be healthy, so it doesn't go or just use too much CPU.
Maybe.
I think more on the side.
Yeah, the CPU. I don't know about the ooming. Yeah, if the centralized cache was still caching in RAM, like you would need the same amount of RAM per instance. Maybe you would need fewer instances. So there could be a benefit there. You could also imagine spooling things out to disk and indexing them, right? It's not an option that the Rego cache currently offers, I don't think.
I guess we could do the same way as like we did for audit, right? Like we save it to disk and then we just read from disk. So this would enable that sort of behavior.
Yeah, and that would be like a easy, quick way to extend Gatekeeper to support that kind of data warehousing. If it's common enough, maybe we want to support that in other ways too, because there will be like extra network hops, right? And also the more systems that need to be up for a request to succeed.
Yeah, I mean, it's definitely not like a silver bullet. Definitely, it's the pros and cons for each approach.
Yeah, and there's nothing to say this couldn't be a waypoint on doing something else. Again, none of what I'm saying is recommendation. It's all just like clinical noticing stuff.
Yeah.
But
just comment. I think if we can do like a JSON sort of thing, like write to disk, just like we did for audit, right? So this then it wouldn't need to be memory, because in for Rego we have to use memory.
Yeah, I was also gonna comment on the centralized thing. There's obvious pros and cons with that. Right now, you may reduce the overall memory or disk resource consumption, but now you have a single point of failure.
I mean, we already had single point of failure, no?
No?
But you've extended the chain, right? So right now, let's pretend you have a Kubernetes cluster with one API server and one gatekeeper node, just to keep the math simple. In order for that request to succeed, the API server must be up. And let's say gatekeeper's failing closed, again, to keep the math simple. And the gatekeeper node must be up, right? And each of those is going to have some probability. Let's say that it's 99%. Probably it's higher than that, but it's going to be 99 to the power of 2, right? If you add a third server to that chain, where if any one of these servers goes down, the request cannot succeed, and that server is also 99% available, it's then 99 to the power of 3, right? And you get this exponential decrease in reliability. Again, that's not saying you shouldn't have multiple servers, even multiple servers in the critical path. It's just when you design for availability, you start thinking about like, well, failure behaviors, and well, we need to like scale horizontally so that we're not dependent on any one server or any one failure domain, so we can push the number of 9s out a little further. So the larger point is having like an extra node would tend to decrease the reliability absent some kind of mitigation.
I guess where I'm going with this is like, if we were to have this external data provider act as like the centralized cache, in order to support, HA kind of thing, like we will have multiple instances of it, right? Like, so I think the nice thing of that is like, the sort of the roles and responsibilities, just because this cache is down doesn't mean gatekeeper is down, right? However, from a total memory footprint perspective, we're just kind of moving the problem. Like, it's not like they're gonna get less or anything.
Yeah, I had the similar thought. Like with HS setup, it feels like we are just moving from one part of the chain to the another, and we are adding additional complexity. So does this trade-off kind of make sense or not? Or what? How should we evaluate if we have to do it? One has to do it.
Yeah, and you're moving behaviors around, right? So gatekeeper stays up, maybe other rules can be enforced, and then your referential rules are enforced best effort. That's kind of cool. That's enabled here. With regard to the referential stuff, depending on your availability requirements, you could have one pod and it like folds, all the requests fold into that one data warehouse pod. And that could make sense if you are well behaved when that pod is down, right? If you need more availability, then you start needing to be fancier. You for sure need multiple pods. You probably need some kind of like data redundancy thing. You start getting into like ring databases or something like that if you want to like scale serving capacity, scale data hosting capacity, and not just have like full replication. Or you could go with full replication, but then you're spending maybe as much on RAM all told as you previously were. And then also, when you think about the number of requests to the API server, if you want to minimize those, either every pod is talking individually to the API server, which, you kind of get to the same situation as multiple gatekeepers, or you have like a controller node or a leader node that is, I talk to the API server and I broadcast the state to all these other pods, right? And there's been plenty of designs that look like that historically, but that's pretty complex, right? So you start getting into the ongoing cost of maintaining that footprint, rolling it out, the engineering cost of designing it. So whether it's worth it or not is like very case specific, right? Like, how much is that extra RAM worth to you that Gatekeeper was using? How much does it cost when things fail? How much does it cost to develop and maintain this stuff relative to those costs of when things go wrong, right? Because right now we're kind of like cheap in the sense of, believe it or not, we're keeping things as like architecturally as simple as we can. But depending on people's needs and their capacity for spending, you can certainly push the failure and RAM usage and all that around, just not for free.
Yeah, makes sense. Actually, Rita also brought a good point about the latency. Like technically, if we want to put it on a different nodes, then how that network latency gonna look like. So maybe that's something we need to consider as well. Cool. Okay.
And there's there's also failure domains. Like if the problem is you're out of RAM, just because you have no more RAM on all your nodes, this won't help with that. You'll still need to have enough nodes to at least cache one copy of etcd, unless you want to reach out directly to the API server, right? But then you get into the write amplification issue. Or read amplification, sorry. So yeah, it seems like a thing you could do. Like I don't see any inherent problems with it. I don't know if I'd want to like write a constraint template for the library that assumes something like this would exist. Just because. Oh,
I was
good.
going to could this be like a generic thing? Like, is that even possible?
Oh, what be a generic thing? In what way
like
generic?
like a external data provider that can do this for all Kubernetes objects.
Yeah, like you could imagine if the key was basically the URI of the API server. Like you could get lists of objects, you could get individual objects, you could get every different kind, every different version. Yeah.
But just to clarify, Max, I think let's say tomorrow, if this provider existed, you're still saying we are not like getting rid of like the informer cache in Gatekeeper, right?
I mean, we would never get rid of that
Right.
just because backwards compatibility, if nothing else.
Right,
Yeah,
right,
like
right. But
people
like,
wouldn't have to use it.
right. But like the guidance would be like if you have this and you're okay with the say the network latency or topology in your environment, you would use this instead of like syncing the resources, right?
Yeah.
Is that the general idea?
Yeah, it could be a drop-in alternative. Personally, I would be a little leery of it for particularly an admission use case because of the latency, because of the amplification stuff, right? Like audit, we don't have control now, but you can imagine exerting a little bit more control around like throttling, better cache TTLs, so you're not requesting multiple times, at least within an audit session boundary, that kind of thing. Another way you could do it, at least eventually, and this is a long from now, eventually, I don't view this as easy. OPA has a pluggable cache object, right? Like the data store, they call it inmem, is a thing that gets dependency injected, right? When you bootstrap OPA, there's no reason why you couldn't have a data layer that either reached out to local disk or over some like network interface or whatever. You would just need to satisfy the storage interface. So again, that's probably a heavier lift than what we're talking about here in terms of like getting something minimally functional. But it could solve the memory problem at least by letting you trade memory for disk. And if you could cache things, you might not take too much of a performance hit, particularly if you have SSD rather than spinning disk. I'll also say, with regard to like reaching out directly to the API server, I think this is something Caverno does. So we can see whatever kind of like, success or failure or problems or side effects they've had doing it that way themselves. And, there's no reason to find out our own lessons when they've already been learned elsewhere.
Yeah, there are also other use cases, like I think Kybernet does it for like the Kubernetes like API version, because today that's not possible unless we use this or like bake this into Gatekeeper.
What, for the Kubernetes API version?
Like taking like the Kubernetes server version, right? We cannot do it. There is no object to cache for that. If you want to check, hey, this resource must be deployed to Kubernetes 128 plus, sort of like that sort of logic.
So like a constraint that's like sensitive to, we don't expect to see pod security policies.
Right, something like that. Yeah, checking API versions, checking Kubernetes server version. That's not exposed to like just objects.
Gotcha. Yeah, that could be another type of data provider too, right? Like,
yeah, something like this or another one. Yeah,
and some of that stuff, right? Like the cluster version, that doesn't change very much. Like, I don't know, change management wise, right? Because the API server can be upgraded without taking down the nodes, right? Like, how would you know that there's a new API server out such that you need to update your cache? But
say only deploy resources to not end of life Kubernetes clusters, something like that.
Right. Yeah, I was thinking about the freshness if you wanted to try to cache versus like always forwarding to the API server.
Are you done with this? I want to come back to the latency stuff. Are you done, Sartaj? Okay. Are we at all worried about the request latency?
Kind of. I don't see much use for this in mutation, right? And that's where latency is most critical because mutation is additive, right? Every request is done in serial. Validation, the requests are done in parallel, right? So you could get away with being a little bit slower there. That being said, with like read amplification, like basically I would be concerned about the API server itself getting slow from overloading.
But I again, my assumption is how you're watching the resources from the provider is no different than how we're watching it today in Gatekeeper, right?
I don't know. Like maybe if that would depend on if when you receive a request for a novel kind, do you establish a watch or do you get it directly? Right. That wasn't really covered in the demo, so could be either way. And if it's a watch, then you need to have the RAM to support that watch. And if you want to have some kind of garbage collection, like I have not received a request for this particular kind in the last 10 hours, I'm going to remove it. Then you need to run a relist, right? If you then receive a request for that kind. So there's trade-offs, right?
Yeah. And I guess like how you configure, say, the cache TTL, maybe, right? Maybe if you have like a longer TTL, there's less hit to the API server, but obviously the data is not as fresh, so there's always trade-offs.
Yeah.
But I can imagine then there's the trade-off is there's less hit to the API server, but now for each request that cares about, that is calling this referential policy, it could add time to the request, overall request time. I don't love that part.
But don't we cache on the gatekeeper side?
Cache what?
Just request. So it would be cache on gatekeeper side and on the provider side. So it wouldn't actually, for every request, it wouldn't go out because gatekeeper itself would cache it. It's the 3-minute TTL thing.
Yeah, but that's the thing, right? The current informer cache, we don't have 3-minute TTL. And so there's sort of like you know the data is more up to date. If you had
Oh,
like
I see what you're saying. Yeah.
yeah. So there's balance, trade-off balance between caching less hit for API server, but more stale data. But still, the overall request time is going to be more, right? Because now you have an extra hop.
Yeah. I guess go ahead, Max.
Yeah, I would be curious. I would think the lookup time in the case of a cache miss would be more expensive than the actual network hop, but I'm assuming that all cluster traffic is fairly close to each other. So that maybe that's not realistic. I actually don't know.
I was going to say this brings one sort of different behavior. So today, if you use the informer cache with both admission and audit is, I think, just restricted to the informer cache. Is that right? So
Audit is restricted.
Oh, sorry. Go ahead, Max.
Sorry. What? I think I missed your.
So if we for audit, if we use the audit from cache flag, that restricts audit to the informer cache. Is that
correct?
Right?
Yeah.
So with this, I guess we are not bound to that. We are so in the current thing, if you have a non-referential constraint templates that needs to check the API server, they can't. Everything must be in the cache, right? So say you have like an unrelated thing like that doesn't need to like cache in the for audit, you're still restricted to that. So, but this would allow like best of both worlds in the sense that we are caching, but we are also coring the API server at the same time.
I don't know if it affects audit, to be honest, one way or another. So audit from cache, I think you're right, is that's kind of like nonsensical using that flag with this, right? Because sort of the definition is you're not the usefulness of this. The idea is you wouldn't cache stuff. So
yeah, no, I meant the caching in the provider itself, not right. The audit from cache flag. Yeah.
But regular audit, right? So not audit from cache. You have a single process, right, that is reaching out to the API server, scraping, getting data, analyzing that data. If you had a provider, and right now there's no mechanism to say scrape this provider as a source of audit, right? So that would be novel functionality, but let's assume it exists. If you did that, then basically you would talk to the provider, say, hey, provider, scrape the API server, give me the results, and I will run audit on those. And so it's the same request volume, I think. It just follows a slightly different path.
And I don't think we've ever really looked at using provider instead of like the audit from cache mechanism. Like if you were to use a provider as the cache, like how do
the flag doesn't make sense for that behavior. Yeah.
Right, I'm saying this. My assumption is this is not for audit, right?
Like you could create, and this is starting to turn into a different proposal. If we're thinking about this way, but you could create like an audit source object that was just a host name and it had some API. We reached out, Gatekeeper reached out saying, yo, give me some objects and I'll audit them. And then like which objects were returned and how they were persisted, how they were cached, would be up to this audit source thing. You know, and then you could maybe do things like controlling visibility, right? You get more granular control over like what gets retrieved from the API server and how. You kind of get that audit from cache behavior. You kind of get that scraping behavior, and you kind of get the ability to kind of do your own thing at the cost of more infrastructure complexity. You're running a separate webhook and the need to like write that code to do your own thing. I don't know if this necessarily would be also a data provider, right? Like it could pull double duty as that, right? There's no, because data providers, right? They'll just return responses to requests, right? And if you wanted to come up with some mechanism that there's like a shared data store or whatever, for sure that's possible. But I don't see how you would use the thing, this putative server's role as a external data provider to define what you should cache for audit, right? Like those seem like different sources of truth.
Yeah, for the sake of this proposal, can we just focus on for referential? Like that,
Yeah, so
I
I
think
was thinking
always
about the current behavior, right? For like the differential, say we have like a unique ingress, right? And then if we have another that's like say like allowed images, right? Allowed tags, whatever. And then we are just going to look at the informer cache. So we turned on audit from cache. Unless we sync all the pods because of the images policy, the images policy would just not audit. So with this data provider approach or some other approach, we would get the cache benefits as well as coring the API server.
yeah, but
today,
there,
if you go
but
ahead.
there are different problems, right? Like this cache, as far as I can see, is for one constraint, whereas the audit from cache is for all the constraints. It's for, right? It's different.
Like if you wanted to support a referential constraint that read ingresses, right? The data provider in filling that role would probably have some data about ingresses, but that's not going to help you audit pods.
Yeah,
so
exactly.
You configure the thing to also watch pods.
So I think that if you add a referential policy, right? If you have any other policies, basically you cannot use audit from cache today. So that's what I'm saying. So this has other implications too. That's like benefits that you can use. It's like best of both worlds.
If you have a referential policy, you cannot use audit from cache.
Why
No,
not?
if you have a referential policy and another policy that's non-referential, say like looking at images in pods, right? Unless you cache all the pods, say you have like 10,000 pods versus like you only care about maybe like 5 ingress, right? So now you have 10,000 pods cached for no reason, which is increasing the thing just so you can use audit from cache.
On the other hand, you still need to cache those pods somewhere, right? Like they're being cached on the data provider like thing.
Yeah, the point is audit from cache, you need to cache everything for all the constraints, whereas referential is you only have to cache the thing you're referentialing on. That's not a word, but you know what I mean.
Yeah, exactly.
Yeah, so two
Because we
different
kind of bloat the cache because like we're just like even though we just wanted like 5 ingress objects, now we have like 10,000 pods.
Right. My question would be like, what have we improved at that point? Like you could move, you're maybe moving from RAM to disk. I could see that.
But cache already, oh sorry, audio already has the cache to disk feature, so we're also not buying much there. Again,
Right.
I feel like these are two separate problems. Like I don't know why we're mixing them. I think it's
Yeah,
making,
that's a valid point for the disk.
and we just focus on referential, I guess. Because I see the value of referential, because like you said, like the Kubernetes cluster, like API server version, right? Like that is actually not possible today. So that's like a differentiation of this provider, right?
I actually would treat that as a slightly different provider, because there's reading the cluster version, that's just straight up not a KRM resource, right? So that feels like kind of a different use case than the we will take the place of referential caching. That seems to be like a pretty clear, yeah, you could write a data provider for that. It would have different semantics than the one that would cache resources. I don't know what to do with that observation other than say that one is a much more clear yes to me, right? Because there's just no other way right now. Whereas the other one, I think we're like weighing trade-offs.
Yeah, that's a good point. I added in the notes. I think it's good to separate them because it's not a resource. Okay, sorry. I had another question about like what happens if you have like multiple of these type of providers and they are living off of different nodes. So now there's extra hops. Because it's not just one provider, right? Say if you have like multiple providers that is caching.
So why would this are you talking about you'd need more than one provider to support referential alone, or are you talking about multiple providers because there's more things than referential?
Referential. Or are we saying the recommendation is in a cluster, you should only have one such provider where you're, caching the KRMs?
Yeah, there's some flexibility here, right? Like you could run a provider as a sidecar. At that point, you're really not getting much use out of this provider model. But you wouldn't have network hops. You could run it as like a singleton process and sort of control where it's running. You could run it as like a network endpoint, and God knows how many pods are backing that network endpoint. There's list requests would be interesting there, particularly if you needed to paginate, right? Like that resumption, if you wound up hitting a different node than your initial node that you hit for the listing. Yeah, sorry to like go on a long tail there, but there's just like a lot of unknowns about how this would be implemented that would affect how true what you said is. But I would assume at least one network hop, right? You have at least one node. If I use like ring type databases as an example, maybe two extra network hops, right? One node acts as like the controller node and forwards the requests on to others to retrieve them. That would be a way to solve like the list consistency issue, for instance. Let's see, is there any other? Yeah, I would assume 1 to 2 hops would cover pretty much 0 to 2, because sidecar would cover the range of possibilities.
What's the second hop?
So the second hop would be, let's assume that you want to have more than one node, right? Because you either want redundancy, or the data set is too large for the amount of RAM you want to have per host, or I don't know what, there's a reason we're splitting it out from Gatekeeper, right? And presumably that also has implications for the type of infrastructure you choose for the provider. Then you would need potentially, like, so in the case that you need more than one node to store the provider data, there's kind of 2 models that you have for that kind of distributed database. Either the client knows about all possible database nodes that it reaches out to, right? In which case you have 1 hop, but you're making a lot of parallel requests. And the networking gets a little wonkier because it's like the client needs to know more than it would for most standard usages. Or you have like your leader election, right? And you have like this one Sentinel coordinator node that is the one that the network requests get routed to. And it has enough state to know which pods it needs to reach out to satisfy a request, right? Like if you're listing pods, then nodes 3 and 4 contain all of the possible pods that could be listed, or whatever. And then it collates that data and returns it. And that has the advantage of it's a little bit more consistent of a networking experience, and you don't need to worry about resumption if you're paginating as much. But you get an extra hop. I'm not aware of anything that has 3 hops, so that's why I say like 0 to 2.
All right, on that note, this is a good discussion, and let's pick it up next time. I just felt like this is like a rabbit hole. It just kept going. It's good discussion though.
Yeah. Like the observation that you can split it out, basically, then it's accurate. But then the question becomes, well, what are you gaining? What are you losing? And how do you tweak those trade-offs? And usually that's with like more development effort, a different shape, more complexity. So the mere observation doesn't quite cover the whole story. Doesn't mean it's a bad idea, just means there's more to it.
Alrighty, I gotta drop. Thanks everybody. Bye.
Thank you.